combination used to identify a network ID and host ID of an IP address. So we will later see what are the what is the network ID or host ID, and this is an example of subnet mask. You have actually most of the time you have come across this. You have seen these subnet masks, and also prefix length. Prefix length, as I said, this is another way of expressing the subnet mask. So yeah, prefix length plus net mask. Actually, it has a very direct relationship. Uh, when we take prefix length, we can find the subnet mask, and from subnet mask we can find the prefix length and vice versa. So this is how we find, or, or we this is how we can find subnet mask from the prefix length. So uh, if we know the prefix length, for example 24, what we have to do is we have to write down first 24 bits of uh, 24 bits in one. Right? So all 21st leading 24 bits will be one, and the remaining bits, that is 8 bits, will be 0. So when we write down the prefix length in binary numbers, then we can convert that binary number into the decimal number, that is human readable number. So each octet, 8-bit octet, we convert into decimal. So all one means 255. So likewise, the value will be 255.255.255.0. That's how we derive subnet mask from the prefix length. And network and host bits. So what are the network bits and host bits? So when we take IP address, it have a network identifier and host identifier. So network identifier has has network bits, and host identifier has host bits. So here uh, here if we consider the above network mask that we considered earlier to 255.255.255.0, it has prefix length of 24. Then we have to determine the network and host bits, we have to write down the IP address in the form of binary number like this. Then we have to then we can consider first 24 bits as network bits and the remaining 8 bits as host bits. Network address. Network address is actually the first address in a network, and is used to identify the network segment. So and here is an example, 192.168.1.34/27. So it has the same subnet mask and prefix length as the previous example. And to find how to find the network address when we are given a IP address. So say our computers assign this IP address with this prefix length or subnet mask. Then we need to identify what is our network address. Maybe what is our broadcast address. What are the other address boundaries in our subnet. So in order to do that, actually, we have to write down the IP address in the binary form like this. Then also we have to write down the subnet mask in binary form. So it will be like this. So then what we have to do is you can identify the actually as I said the network bits first and host bits. So in this example, host bits are last 8 bits, right? So what to find the network address, we make all host bits 0. In this case, the the numbers with red color, we all make them 0. Then we can have the binary number, binary representation of the network address. Then again we translate it back to the decimal form. So the network address will be 192.168.1.0. So that's how we find network address when we are given an IP address. So how to find the broadcast address? So broadcast address is actually the last address in a network or in a subnet. So actually broadcast address is used for addressing all the hosts in the network. When we send the packet to when we send the IP packet to the broadcast address, it will be sent to all the hosts within the same subnet. So here from the previous example, so as in the previous example, we have to write down the IP address in the binary form, then the subnet mask in the binary form. Then actually we have to match. So we have to find the boundary where the host begins and
when we are considering IP address, we have to
begin.
we have
So
to get
as
idea
in the
about the network mask
as in the
also.
previous
Network
example,
mask also IP address. Basically, IP address.
as in the previous example, last 8 bits will be
if
the
I
host bit.
make
So
IP address
in order to find the
an IP
broadcast
address
address, we have to make
method,
all the host bits once. We made then we
IP
can
address
get the relevant binary address of
is
the
made
broadcast address. So
it's
from
made
that
with
we
32
have to
bits
convert
binary.
back it to the decimal form. So
Is a
convert
IP
it
address is a
into
32
decimal
bit
form, we can get the
decimal number.
Broadcast address in decimal form. So it will be the 192.168.1255. That's how we get we can find the broadcast address when we are given a network address. Sorry, when we are given an IP address. Next, we see into what is subnetting and how to we will look into several examples of subnetting. So we are going to look into equal fixed length subnetting and some variable length subnetting. So first we'll see what is subnetting and why we subnet our network. So subnetting is actually, as you can imagine, dividing a computer network uh, into multiple logical networks. That is uh, dividing a network into subnetworks. So why we should subnet? Actually, it improves the network performance and the speed. Uh, how it improves? Actually, you know, for we can have, if we have a large subnet, that means that accommodate maybe say 1024 or so larger host, maybe 2000 or something larger number. So say that number of hosts are in the same subnet. So within such subnet, there can be actually many broadcasts. When a person send a uh, broadcast or host, some host generate a broadcast packet, so that broadcast packet is sent to all thousand or to that much of nodes. So imagine when all the users or all the host or laptops or computers connected are sending broadcast. So then when it happens, the network bandwidth or network capacity is consumed. So the network actual usable capacity is very much reduced. So that actually the network performance and speed will be drastically reduced. So finally, what happens is the network will be unusable. Um, then we subnet our network to reduce the network congestion. Uh, Actually, when such a broadcast happen, uh, again the that again much of much of unwanted traffic is generated throughout the network as well. Maybe when the network is larger, all users are communicating and much of the bandwidth is consumed. So maybe uplink uplink port of the subnetwork is consuming much of the bandwidth because larger number of users are using uh, that subnet. So uh, so that the network congestion happen. That means network congestion, when network congestion happen, actually network is literally unusable. So when we subnet the users, subnet the network into smaller ones, so this does not happen. So network is most time free of unwanted and traffic, so that the network congestion does not happen and network speed is secure. Then it enhances the network security. Imagine all this in your campus network, you have flat network. That means your network is not subnetted. You have 300 users and 500 users. You have a single subnet. So all the users are connected to a single network. So your network can have important servers or important services. Maybe your computers have important data and things. So if someone who attack or someone connect to your network, so it is very easy to see. Actually, you are every attacker can see any traffic connected to that single subnet. So the attacker can easily breach or easily connect your server or any computer. So that's why we subnet. So by subnetting, we isolate important devices or important information or important networks into separate subnet. So important device into separate subnet. So that actually one who connect from outside or any attacker can't easily see uh, it is not actually those servers or any uh, information, those servers will not be visible to the attacker. So also it simplifies the network administration. Actually, users, the network admin can easily manage users. If the servers are in a separate network or the lab some labs are in a separate network, administration or student or guest are in separate networks, then we can apply firewall rules or any filtering uh, for each VLAN or each subnet easily. So without, otherwise we will have to add, actually it is not easy, otherwise it's not feasible to manage, apply rules for when all are in a single subnet. So it make it easy for the administrator to uh, administrate the network when the your network is subnetted. So we'll see now into IP address classes. Actually, what the reason I discuss about IP address classes is because of for the learning purpose. Because these IP address classes are now kind of deprecated. Not actually deprecated, not even not in recommended level. So but we can now the current uh, classes, actually this IP address classes are replaced by the concept called CIDR, that is classless interdomain routing. So we nowadays can use CIDR instead of IP address classes. So here are the some actually IP address classes. In past, actually IP addresses were divided into 5 classes. The from actually you can see the first octet decimal range from 1 to 126 and belongs to the class A, and likewise 1 to 8 to 191 belongs to the class B, and likewise it has ranges. Also, when we consider the binary format, we can identify the class by looking at the higher order bits. Actually, if it is a higher order bit is 0, it belongs to the class A, and if it is 10, it belongs to the class B. Likewise, as shown here, it will belong to the particular class. Uh, for actually for the IP address classes, it originally actually it had a default subnet mask. Normally at that time, particular subnet mask, we couldn't go beyond that subnet mask. We had to accept that, and we had to adhere that concept. The original subnet mask for address class A was actually like when we separate the address into dotted decimal notation, the first octet for first octet, first 8-bit have the network ID, and the other three remaining bits, 24 bits will be the host ID. So for that particular A class network, as you can see, the default subnet mask will be this 255.0.0.0. For class A addresses, class A networks, as you can see, it has somewhat it can have subnetworks. It can have number of networks like 1 to 6. So it's somewhat smaller number, but it can, since it has a larger host bit, that is 24 length host bit, it can, that class A subnet can have host of this much. Actually, it is something 16 million something host bits. So it's a very huge number. So likewise, for the class B addresses, network ID or network bits will be 16 bits, and host bits will have 16 bits. So the subnet mask will be 255.255.0.0. So it has this much of number of networks, and this much of host per network. So it is normally compared to the class A and class C, it's somewhat number in the middle. So for class C, for a class C network, for a class C network, actually the network ID will have for 24 bits, and host ID will have 8 bits. So that default subnet mask will be 255.255.255.0, and so that number of networks that class A class C can have is this much, 2 million something. That's a very big number. So, and host per network will be 254. We'll see there are formulas to get simple formulas to get usable addresses and number of subnet. Very simple formulas. We'll see when we are doing some examples. So, and class D addresses are reserved for multicasting. Actually, IP version 4 do have unicasting. Actually, most traffic goes to unicast, and other is multicasting and broadcasting. So Anyway, class D is reserved for multicasting, and class E is reserved for experimental and use of for research. So that's how the IP address range into divided into classes in the past, and about their default subnet masks and things. So, and private IP address, right? You know, you actually already should be using the private IP addresses, because we are actually provide some amount of public IP addresses, but they are also not enough for your when if you assign those public IP addresses direct to your users or servers. So that you have to anyway use private address spaces. Actually, private address spaces are reserved for only used within the local area network or private networks. So those private address spaces cannot be routed, and so cannot be routed on the internet. So that anyway, private address spaces here we actually the INA has reserved three address spaces from three classes A, B, and C. So here 10.0.0 with the subnet mask 255.0.0 and with the address range from 10.0.0 to 10.255.255.255. That's that that is the actually biggest private IP address range that is reserved, that we can have for our LANs. So, and other one is as you can see, this range 170.72.16 to 10.02 172.31.0. So that's also somewhat bigger address space, and other address space is 192.168.02, and with this address space, the given address space. So actually it is smaller than other two address spaces. Uh, when we uh, when we uh, when we design our network, and we have to uh, actually think about what address space should be used within our network. So in most cases, these all address spaces can be used within your network. If imagine if it's a very large network, you can choose class A or class B address space for your network. So depending your requirement, you can choose one of these address space for your local network. So now we are going to some subnetting examples. So how to do subnetting, and to do subnet, we have to actually divide or partition a given subnet, or whatever the subnet we choose, we have given, or we have chosen. So in this example, actually I have taken the address actually the subnet 192.168.10.0/24. So in this example, we have to divide this network into four subnets. So let's see how uh, we do this, and what are the procedure we should follow to do this. And first, actually, I will mention that simple formula to calculate the subnets. Actually, this is 2 to the power of b. B means borrowed bits. Actually, uh, borrowed bit means when we subnet a given network, we have to extend the network bits uh, to get our required subnets. So we have to extend bits into towards the host part. So that number of bits is called the borrowed bits. In this example, we have to create 4 subnets. So the equation is 2 to the power of b, so it should be equal to 4. And so from this equation, we can get b equal to, that means borrowed bit, no, number of bit is 2. So this is how this is how it is represented. So this is the subnet, the original network given, and so when we this is here it is clearly shown a number of borrowed bits 2 and remaining 6 host bits. So actually that network can have each that subnet can accommodate actually number of hosts actually with equal to 2 to the power of 6 minus 2. We'll later see in next slide that equation. So this is actually some lookup table. If you are not comfortable calculating this you are not comfortable with these binary numbers, you can use this lookup table. Image actually this is for class C networks. So with the subnet mask 255.255.255.0. So for class C networks, we can use this lookup table. We can, by looking at number of borrow bits, we can have the number of subnets, and we can have the number of hosts. So we don't have to worry about the binary calculation. And so in next example, we are doing the other way around, that we are given a subnetwork. So 192.168.1.0/25, which is actually classless one. If it is classful, it should be 24 subnet 24 prefix length. Since it is not 24 prefix length, and we call it a classless network. So and we have to here create a subnet with 6 hosts for each subnet. So let's see how we can find the uh, uh, number of subnets when we are given with the network and the number of hosts. So actually the formula is 2 to the power h minus 2 for the user number of usable host addresses. Actually, h means the host bits. We know that there are 2 bits type of bits, network bits and host bits. So here we do we are here we so actually we have to reduce. That is, we, we are in this formula. There's a -2. That means we are removing 2 addresses from the usable host addresses when we are given a network, because normally we know the first address, the network address, and the last address we earlier discussed, the broadcast address. We can't assign them into the host or network interfaces. So we have to remove or reduce those 2 addresses, and that's why there's a -2 in the formula. So in this example, we have to have 6 hosts. So the equation is this one: 2 to the power minus 2 to the power h minus 2 equals 6. From that equation, we get h equals 3. That is host for that number of for that kind of subnet. For the given subnet, we have to have 3 host bits. So when we write down this subnet in this binary format, here we can easily see the host bits is 3. So the remaining 4 bits will be the borrowed bits. So we can create actually a subnet using these 4 borrowed bits. So the number of subnets will be 2 to the power b. So b is equal 4, and then so I think this is somewhat yeah, there's a mistake here, sorry for that. So b should be 4. So 2 to the power 4 means 16. Yeah, we can have 16 subnet. 16 subnet, we have to make correction. Yeah, it is we have to yeah, 16 subnet, number of subnet is 16. Then we'll see that into next subnetting topic that earlier we saw discuss was actually fixed length subnet. Actually, we subnet with the we were trying to get all subnet with equal subnet mask and equal host. So in this case, we are going to discuss about when it comes to change actually variable. We can have actually in the real case actually normally all the subnets are not going to be equal. Actually, when we subnet our network, our campus network into groups, normally each user in each department or any kind of division is different. So in this example, as you can see, different department or different groups have different number of people or hosts. So that in such cases, to avoid waste of address space, we use this variable length subnet mask. In variable length subnet mask, actually, imagine that we are using fixed length subnetting in this for this example. So we are assigning subnet with subnet that can accommodate that can accommodate 120 126 hosts, right? Then if we get yeah, it will be okay for students, because for that for a subnet that can accommodate 126 hosts, one 110 students. So there's no much wastage of IP addresses. But in the case of others, actually, there's a much wastage, and for example, here only two administration staff is there, but when we allocate 1 to 6 addresses, there's a much waste of the addresses. So also we can't assign small subnet, because there are, if we assign a subnet that can accommodate, for example, 14 hosts, actually only this one administration staff, accounting staff, and library staff subnets will go with that subnet, but that can't accommodate these 3 subnets, because if it is subnet can accommodate 14 hosts, it can't accommodate this number. And so for above example, what will be the suitable IP address space or IP address class to be used? So we can use any of the thing, but we can use 10 dot, we can choose from the private IP address from 10.0.0.0, or we can choose from 172.16. That the space, okay, we can choose from 192.168 something. So here I think the class C address, class C subnet will be actually suitable uh, for this example. So I am in this example I have chosen this subnet, this network. So 192.168.100.0 with subnet mask prefix length of 24. So let's see how we can subnet this given network to accommodate this example. So before that, actually, I am going to tell you about some simple process or simple steps how we can use this variable length subnet masking. For variable length subnet masking, we have to follow the below simple procedure to subnet your network with the given requirement. First, you have to sort the requirements or subnet by the number of hosts per subnet in descending order. So, and then you have to allocate the highest range of IPs. If from the given network to the highest requirement. If that means in the previous example, so highest requirement was 110, 110 students. So it will be given the first addresses, first number of addresses from the given network. Likewise, we have to choose the next highest requirement and assign a subnet with from the given network. So likewise, we do until all the requirements are given a subnet. So this is the answer, and in this answer, as you can see, we have given the first subnet. So first number of a subnet. So to the maximum requirement. Likewise, we have done that. So I say you this subnet has actually the IP address range from 100.0 to 127. So that is the address range for this requirement. So this has next address subnet comes from 100.128 to 100.191. Likewise, the subnet will be assigned to these requirements. Actually, we can see earlier we had actually fixed length subnetting. In there, we had a subnet mask or subnet with fixed size. So here you can see the prefix length or the subnet mask will be different from for the each requirement. That's why we call subnet length subnet masking. Variable length subnet masking. So this is actually a very efficient method of allocating address space. So actually for most of the practical things we should follow variable length subnet masking. So next, let's see what is classless interdomain routing, CIDR we call. Actually, this is the concept of technology that replaced the deprecated class-based subnetting. So actually, so as I said you, the class-based subnetting is a wasteful of addressing, and also it has many problems. We'll see what is class CIDR and how it is useful in subnetting and actually in routing. So CIDR is actually based on the concept of VLSM, and it is like VLSM. It can have actually variable subnet mask. So that's why so it is like VLSM, and about it is actually as I said, it is a replacement for the deprecated classful IP addressing, and it's a flexible way of allocating IP addressing. And it is as I said, it is all efficient. When we allocate address space, no wastage will be there. As you can see, it is when we take routing, so dynamic routing, we always have to consider about the routing table size. When a router connected to the BGP, with router has BGP configurations and running BGP. BGP routing table has a large number of routing entries that is coming announced from the internet. So imagine actually these are private address spaces. We are not announcing private address spaces to the internet. Imagine these are real IPs, right? Real subnet. So what if we are going to announce? Actually, these are Class C subnets, Class C networks, and this is 192.168.1.0.2 this 192.168.254.55.0. So altogether it has 256 networks. So imagine we are announcing these IPs, these networks through BGP to the internet. So there will be 256 entries altogether. So likewise, if everyone starts to announce this way, so internet routing table will be very large and can't be accommodated in routing existing routing table. So that's in this case we can follow the CIDR concept, and we can actually aggregate, or we can summarize these 256 subnets into this subnet, this sub network that is 192.168.0.0/cc. So if we summarize that like this, there will be a single entry. So the routing table size will be reduced, and so it is good for BGP routing. Then we'll see into CIDR notation, that is how we can how a network address or network address or IP address can be represented in CIDR notation. So in CIDR notation, network address is followed by a / and followed by a network prefix length. So that actually that's the thing I was always be using in this presentation. So that's the CIDR notation. So these are the some examples of CIDR notation. So as you can see, this is some network, this is some IP address, the second example, and in this third example we have summarized some of four subnets, like 4 networks into a single network. Supernetting, actually supernet, some people interchangeably say use the term supernetting and CIDR when supernetting is also actually same as CIDR, and it is summarizing a bunch of contiguous networks to form a large network. Actually, what is happening in the last example is the same as that. This is some continuous or contiguous networks, right? If it is continuous, we can summarize that that number of network into single network like this. So that is happening in supernetting. Supernetting is used for route summarization. So in route summarization, we use actually as I said, a single route entry to represent multiple route entries. Supernetting is actually supported. Actually, CIDR supernetting can be used in routing protocol which supports CIDR. Most of the routing protocols support CIDR, that EIGRPI or OSPF, BGP, ISIS, and RIP version 2. But RIP version 1 does not support CIDR. So if we configure the supernetted or summarized address in RIP version 1, it will not be accepted. And as I said, these two terms, CIDR and supernetting, are used interchangeably. So next, what we discussed was previous slides was IPv4 4. Now we see something about IPv6 and what is the IPv6 and what are the address format and things. So IPv6, why it is so created actually, mainly due to there are several reasons. One of the major reasons is to expand the address space. Actually, IPv4 is not actually enough for the enough for assigning the for all the networks in the world. So that's why for as a temporary solution, we were using network address translation to mitigate that IP address space shrinkage. And but this IPv6 is a permanent solution for that problem. So it has a larger, actually, it is a very large number, 128-bit address length, and so that it can accommodate very large number of address space. So in IP v6 and v4 addresses both have headers, IP headers. So in IPv6, the header format is simplified. Actually, it has a fixed length, unlike the IPv4 header, which is actually going to be variable, and IPv6 header has actually 40 bytes and it is fixed in size, and IPv6 has a minimum size of header, has a minimum size of 20 bytes, and it can vary with the options added. So if some header options added, it can take very large. And IPv6 normally IP version 4 has checksum. So with checksum, actually we can correct if there's some packet we can correct, and we can check whether the packet received is okay. So whether bits are corrupted or not. So actually checksum is actually a very process consuming thing. So the CPU of the devices will be consumed verifying this checksum. So it will make the packet forwarding very slow, so that IPv6 has removed this checksum in its header. So when consider about subnetting, actually in IPv4 we can have prefix length. We can in subnet we can have prefix length of any length actually, right? So we can have a prefix length. In the previous example, we had prefix length with 24, 25, 26, and likewise we can have 22, like anything 16. But in this example, but in the IPv6, it has actually accepted way of subnet mask and prefix length. It is a fixed thing, and it has 64 bits. of interface size, interface subnet mask size. And authentication, about authentication privacy capabilities, the IPsec encryption is integrated into the IPv6, so it is inherently secure. And IPv6 does not have any broadcast packets. It only have instead it has anycast. Actually, IPv4 supports, as I said earlier, it supports unicast, multicast, and broadcast. IPv6 supports unicast, multicast, and anycast. So as I said, this is some comparison about the address space. That's a big feature in IPv6. So IPv4 is 32-bit long. So the IPv4 has this number of possible addressable devices, and IPv6 is 128 bits in length, and so 4 times the size in bits. So it has this number of actually we can't literally say this number of possible addresses. So it is actually not going to be over soon, or we can't predict it. So about IPv6 address representation, when we consider the IPv4, we represent IPv4 in human readable form with decimal numbers. In here in IPv6, we actually represent IPv6 in hexadecimal numbers, and normally we divide IPv6 address into 16-bit segment. So for a hexadecimal number, we have to have 4 bits. So for 16-bit, we can have four hexadecimal numbers. So 16. When we divide IPv6 address into 16-bit groups of segment, we can instead of IPv4 dotted notation, here we use column-based separation. By 16-bit, we separate this address by colon. So and let's see. So this is an example of IPv6 address, and we are going to do some actually we are going to practice some address compression techniques for actually why we do address compression here, because IPv6 address is very large, or we can't actually remember it. So we need to make it short as possible. So there are some rules for address compressions, or address making it short or shrink, and we'll see what are those rules. The first one is leading serials in this segment, that is 4 hexadecimal number segment, are optional. So if there are leading zeros in address, we can omit that. In this example, as you can see, there are leading zeros. Here in green decimal zero, it is a leading zero. So we can omit that. So it can be written in this way by omitting that. So you may consider that you may think that these also that second segment and fourth and fifth also have leading zeros, no, but it has a different rule. We'll see if all the successive or fields of successive fields are zero, we can represent it as a double column. So we can apply different rule for the second and fourth and fifth segment. So we can represent them as double column. So for in this example, we can, this green part, we can represent them as in double column, but we are not going to represent this the remaining, the second segment, because it says actually we can only represent that successive zero fields with only once, not twice. So so in this case we can consider this fourth and fifth zeros, and we can reduce it to double column. So our purpose is to actually make it shorter, the address is shorter as possible. So we are taking the longest. So we are taking the longest bit sequence, 0-bit sequence, and we make it, we remove it. So this is okay. The second way, the second one, second shortage is compression technique is okay. We can also, actually it is not denied to do this one, that we can actually we can replace the second segment with double column, but it is not the shortest one. So since it is not our goal is to make it compress as possible. So we choose the fourth and fifth segment. So replace them with the double colon. So finally, putting it all together, we can have this address. So also this actually this one also we cannot, as I said, this cannot we cannot replace separate all zero segment or with colon, double colon like this. It is not okay. And putting it all together, actually we can receive this address. This is the shortest possible form we can have. And it's about special addresses like all zeros. In IPv4, all zeros is represented at 0.0.0.0. So in IPv6, we can represent this, or we can compress this into this double colon. So all zeros will be represented in double colons. So another is the other special address, the loopback address. So IPv6 loopback address will be this, and we can compress it to this address. So this is a special representation. These all zeros and loopback addresses are special representation. So that's how actually that's how the whole IPv6 address compression rules and techniques. So when we represent the prefix, it is just like IPv4, and in IPv4 actually we represent address like this with forward in CIDR / with 192.10.0.0, the network address followed by slash and the prefix length. In the same way, IPv6 address can be represented. So we when we represent, we omit actually following zeros. Actually, we can omit all host bits. We can make it all 0. So we can only have only have this network part and followed by colon and followed by / and the prefix length. We represent IPv6 address in CIDR notation. So this is actually the how normally the standard way IPv6 address space allocated. So, normally the INR is the owner of these internet numbers. So INR is the institute that regulate what to do with and how to allocate these internet numbers, including IPv4 and IPv6. And INR actually first INR allocate this subnet, this network at 200:3. That's the biggest unicast IPv6 network that INR allocate. Then that is divided into that is actually that space is divided among the other registries. And actually we have a registry for each continent. That is we are getting from APNIC, that is Asia Pacific Network Information Center. So that is our internet registry. We are receiving IP addresses from that institute. That is the one who is governing these internet numbers for Asia Pacific region, and likewise for any region like for North America area, and like we have for South America, Africa, and for regions we have Europe, and we have region or regional registry to govern these internet numbers. So each registry actually owns a 12 has a network with 12 prefix length. So that is actually also a very huge address space. Then if any ISP request that particular registry for IP address space, IPv6 address space, they allocate normally 30 address space with 32-bit prefix length. So we also learn has this much of address space allocated by APNIC, and that next in the next level. So ISP provide particular customer for address space with 48 prefix length, and we have assigned our campuses and institute this much of address space. That's a very huge number. Actually, you it is not going to be over. It's very unlikely, and so here site means actually a particular business or particular campus or university or some corporate organization. So that the standard is actually that particular campus or organization should allocate subnet for LANs with 64-bit prefix length. We can't actually allocate, we are not actually, it's not recommended towards, we can't allocate address subnet with prefix length more than 64. We can't assign subnet with 65 or 66 likewise, but we can do it in IPv4. But in this case, it is not allowed, it's not recommended. So to allocate such subnet, and so that's how the standard and most standard way of allocating IPv6 address space from register to our LAN network. So that's actually my that's the simple presentation about IP addressing, IPv4 and v6 addressing. So we talk about IP addressing, how to find network address, broadcast address, and how to do subnetting, what are the IP address classes, how to do variable and subnet masking. Very simple things. And we talk about CIDR and SuperNetting and about little bit about IPv6. Do you have any concern or comments? Have one more hour. Another session for VLAN, very small session actually, very overall session. if time allows, we are going to do some presentation on setting up our lab setup. Yeah. If there's no comments,
so if you don't have any comments,
okay.
actually, if you
I'll
have
go
any concern, if you didn't understand something, so we might we will put these recordings soon, so that you can go through it again. So still, if you have some problem, you can contact one of us during the workshop and ask those questions. So with that, that is the end of Lalanta's session. That is the network basis theory part.
I have VLANs.
Yeah, VLANs. So, okay, one more session.
Continue.
Okay, one more session. So after that VLAN part, we are going to discuss about the setting up lab. So we want to discuss the basic stuff of setting up lab so that you all can spend some time overnight to set up your computer and download all the files and to get the basic things done during the night. So Lalanta, you can continue the rest.
Okay, virtual LAN. Virtual LAN actually some we have seen earlier about subnet and local area networks. This is the concept that how we virtually create a local area network. So VLAN is actually some broadcast domain. Actually, in a computer network, which is a partition or created at the data link layer, that is layer 2 in OSI model. So it has the same properties or attributes as physical LAN. So and it allow to split switches into separate virtual switches. Actually, normally in normal subnet, particular single switch is owned by a single subnet. But here we can create virtual switches or virtual broadcast domains from a single physical switch. So and also about this normally subnet or subnet routing or network routing happens through a layer 3 interface, mostly actually mostly if that subnet is connected to a subnet should be connected to a router, so that actually subnet can communicate with another subnet. So normally in earlier days, subnetting is done through the router interfaces. Here, this virtual subnet, so virtual LANs are routing done through a layer 3 device, likewise in router. And we'll see later how this interVLAN routing happens. It is same as subnet routing. So So we use normally this VLANs within we configure this VLANs in switches, and we use L3 switch for normally we can use L3 switch for inter-VLAN routing. So this is how we can logically partition physical switch into virtual switches. Normally, if it is a subnet or network, that particular physical switch belongs to a particular subnet, and in this case, we can when we creating virtual LANs, we can allocate some ports of the physical switch into separate VLAN. So it will act like separate VLAN, separate virtual switches, and it will create separate broadcast domains. So in this case, imagine this is the switch. So first part of the ports are allocated to VLAN 20, and these access ports, VLAN ports, are connected to VLAN 20 nodes. So and these VLAN, the other part of the right part of the switch ports are assigned to VLAN 30, and those ports are connected to VLAN 30 nodes. So these two, VLAN 20 and VLAN 30, are assigned different subnets. So if it is a physical, if it's a normal subnet, all the hosts assigned to that particular switch should be assigned addresses from a single particular subnet. But in this case, we can assign each subnet for each VLAN. So this is how VLAN this is about VLAN trunking. Actually, VLAN trunking is some actually it's a tunnel or some encapsulation technique that transfers the VLAN different VLANs. Normally, this is 802.1q is a standard, actually encapsulation standard. Actually, it's the standard or implementation that implement the virtual LAN concept. And for when we connect here, left and right switches, we can connect these two switches with a single cable. So this is a single wire. So so imagine that first switch is connected to some port and the second switch is connected to some port. We have to make it a trunk port. So trunk port has actually through a trunk port VLANs, we can permit some VLANs. So in this case, for communication between two switches, we are permitting these VLANs, actually two VLANs, VLAN 20 and VLAN 30. The process is called tagging. Imagine that this the left side, the green, the VLAN 30. So VLAN 30 connected node or host communicate with the right side VLAN 30 connected node. So when it when the switch communicate, when the switch send the packet to the address to the right side switch, it goes to the this particular port. So this is actually, these are called access port. Goes through the access port, then uh, it goes out. It has to go out from this port, this trunk port. Actually, trunk port has when when that particular packet is going through trunk port, that packet is tagged. We call it tagging. So the actually that frame header is added the like we call it tagging. So frame header is added the tag bit, so that VLAN 30 VLAN 30 is that packet is VLAN 30 tag. So that tag frame goes through the trunk and come to the this the right switch, and when it comes to this switch, it sees whether the packet is tagged or not. Since it is tagged with the VLAN 30, so it removes the tag and it send only to host connected with the VLAN 30. The switch does not transport or send that packet to VLAN 30 ports. So it send only to VLAN 30. So that is how, in this case, that is how end-to-end VLAN communication happens. But in this setup, we can't communicate from, that is, we can't communicate from VLAN 20 to VLAN 30 and vice versa. So because we need to communicate from VLAN 20 to VLAN 30, we have to have a gateway. In a normal way, when we consider subnet, the subnet has a gateway. We know we do some IP configuration. We have to specify a gateway address, so route IP. So likewise, we have to have a VLAN IP, VLAN gateway IP. We call it VLAN interface IP. So without that, we can't communicate with inter VLAN here. So we can only communicate between the same VLAN. So for routing between inter VLAN traffic, we have to have a as I said earlier, we have to have a VLAN gateway or VLAN interface IP. So it is done through in some layer 3 device, like in here, layer 3 switch is so it has to, that switch has to be compliant with the N-Node 2.1q standard. So then we can define VLAN gateway in this switch, or VLAN, we normally call it VLAN interface IP. So then if we want to communicate from VLAN 20 to VLAN 30, then we send this if a host connected to VLAN 20 send a packet to VLAN 30, then we send the packet to the VLAN gateway or VLAN gateway IP at this switch. Then that switch then it transfers to particular VLAN 30 VLAN 30 at this switch. So that switch then actually the packet comes with trunk VLAN tag with 30 VLAN 30. So it removes the VLAN tag and send to the relevant host. Likewise, in this communication, when it goes from from switch to actually when we consider the communication from switch to host in this part, there's no VLAN tagging happen. When we going through a VLAN trunk, there's a VLAN tagging. That's we add a label that this packet belongs to this particular VLAN. So we add a label there. We call it a VLAN tagging. So until we pass through the VLAN trunk, we don't remove that. We actually until pass through from this part, we have to have a VLAN tag. So there are many setups for inter-VLAN traffic. So one is this is actually another first setup we can have in our normal campus networks. We follow this setup. We know normally this switch belongs to the distribution layer. So we do some normally VLAN inter-VLAN routing at the distribution layer. So we do configure VLAN interfaces or VLAN trunks at this switch. So VLAN inter-VLAN routing happen in this switch. So we can also follow this setup. Imagine in this setup, we trunk actually this configuration is called a router on stick configuration. This is actually this link from router to this switch is a VLAN trunk. So it is encapsulated with this 802.1q standard. And when imagine the VLAN 30 is communicating to VLAN 20, so it sends the packet, and packet is forwarded to interface IP in this router. In this case, the interface IP or gateway IP is configured in this router. Actually, it is configured as a sub address, secondary address. So in this case, we have to configure two secondary interface IPs. That means for VLAN 20 and VLAN 30. So when VLAN 30 wants to communicate with VLAN 20, the packet is sent to the switch, and from switch it goes to the gateway IP of the router, and then it is the router forwards that packet to the relevant IP of the other VLAN, that is VLAN 20. That's how inter-VLAN routing happens. So the other setup, the third setup for inter-VLAN traffic is this one. In this setup, normally in this setup, actually in this part between the router and the switch, there's no VLAN trunking, but VLAN trunking only happens from this switch to this switch and this middle switch to this one. So those are the only VLAN trunks exist. And when there is so in this setup, the router has to have two physical interfaces. So there are two cables running from switch to the router here. And so if some VLAN 20 here to communicate with the VLAN 30, traffic actually the packet sent from this host VLAN 20 will go to the switch and go to the relevant VLAN 20 IP gateway located at this router. Then that router forward this packet through the gateway of the other VLAN, that is VLAN 30. So it forward the packet through that gateway, and it comes to switch, and it goes through the trunk, and it comes to the final destination. That's how inter-VLAN traffic happens. There are three setups. So the most actively used VLAN VLAN routing setup is this one. This is actually done through a layer 3 switch in practical networks. So actually this setup is not much feasible, because actually not much scalable, because it consumes more router ports. Actually, routers don't come with much ports. Actually, routers have few ports, but when it to come to VLANs, you may have tens of subnets of VLANs. So you can't afford the router with that much of ports. So this setup is not feasible. The better way is to go to at least set up the one or set up two. So when you talk about the segmenting with VLANs, the benefits of segmenting with VLANs, there are, we can talk about why actually we use VLANs over subnetting over network segmentation, for network segmentation. Why we should use VLANs instead using subnetting. Actually, VLANs supports logical grouping of host or which is physically dispersed on a network. So actually it is very advantageous when it actually does not need to have actually deep route ready. It does not need to deploy routers on your network. Actually, for physical subnetting, you need to have subnetting. You need to have physical routers, right? So physical routers are at high cost, and they don't have much of ports. So it is not feasible. So that when we use VLANs, we can have layer 3 switches and do have VLANs. So with the layer 3 and layer 2 switches setup, we can have separate broadcast domain through VLANs. So we can achieve what we achieve with the what we do with with the subnetting. So that's the advantage of VLANs, using VLANs, and it is advantage, as I said earlier, the cost effective because we don't have to use routers. We can use only layer 3 and layer 2 switches, and it is very flexible when thinking of expanding a network. When we need to expand, actually imagine we need to create a different subnet for different group, for a different group of people or different department. So we can do it using existing switches. So if that particular group live in the same building, we can use existing switches, and we can actually create another VLAN. We can accommodate that requirement. So that's another advantage or benefit of VLANs over normal subnetting. So that's all about my presentation, and this is actually small overview of the VLANs. So, if you have any comments. If you don't have any comments, we have another some small session, setting up lab and actually preparing for that lab. We'll see whether can be conducted now. Geethika. Okay, I will hand over to Geethika. He will do some presentation on setting up the lab network.
Thank you, Mr. Lalantha. Can you hear me? Guys, can you hear me? Okay. So I will take over from Mr. Lalantha, and actually setting up this lab is need more time actually than the half an hour. But today I'm going to give you a brief description about how to assemble this lab, because without having a proper design, we can't continue with this lab setup. Even though I have a half an hour, I will try to explain what are the basics things that you need to download and install to continue from tomorrow morning onwards. So if I share my screen, so I believe you can see my screen. So if you go to this agenda, the first thing is this one, setting up the lab. So before I go with the slides, I will directly go with the lab setup. Okay. So this is what we have to do before we continue with the configuration from tomorrow onwards. So for this one, actually you have to install some softwares. Okay, one of them are VirtualBox. Okay, VirtualBox you have to install, and you have to install Putty. I believe most of you have already got the Putty, and WinRAR. Everyone knows about that one. And the most important thing is the VMs and the tool that we are going to use for this lab setup. So normally, I believe most of you have familiar with the simulation softwares, okay, Packet Tracer, GNS3, and something like that. So previously, we have done this workshop using the GNS3, but due to the resource limitation of the devices or the PCs or the laptops, we had to go with another tool. Another tool means it's same, the GNS3, same software, but those who have familiar with the GNS3 nowadays, you know that it is a totally graphical and it uses GNS3 VM servers and a lot of stuff. But what we are going to use for this presentation or this lab setup is the earlier version of the GNS3. Earlier version of GNS3 in the sense, in the beginning of the GNS3, before it comes to the graphical interface, they have used a text-based implementation. Okay, somewhat in the beginning it may be somewhat difficult you to understand, but I will go with some tutorials and I will explain how to do that one. Why we use that one? Because it uses limited resources. So with the 8 GB of RAM, we can do that with the one PC or one laptop. So that is the main reason that we are using that Dynagen or the Dynamics software. Some people or some participant maybe you have experience in that one as well. But I will go through some tutorials and let you know how to configure the networking used in that one. In the beginning, it may be somewhat confusing, but because you can't see anything, because graphical things are not there. So you may feel like how to configure without having a graphical environment. But I will go through some examples and I will let you know how to configure that one. And the other main thing is downloading these VMs. So you can see we have, because our network consists of firewalls, and we have to have a web server, and we have our monitoring server, which is run LibreNMS. To communicate with these servers and with this pfSense firewall, we have to use kind of a graphical interface. So in this lab, we are going to use Windows XP instances for that one. So already most of the VMs are configured with basic networking stuff, but some setups maybe you have to do yourself. Okay, so main thing is you have to download these VMs. Okay, in your today night. Okay, most probably with those who are using your private data, you can use your off-peak data or something, and you can download them. I think they are not that big. Okay, they are very limited capacities are there, so you can easily download them. And I believe most of you have the experience of VirtualBox or VMware, so you have to mount these VMs using VirtualBox. And when you download and mount in these VMs on the VirtualBox, we have given some instruction what we have to do. and you can all the whatever the instruction are here. Okay, so when you download and configure the PF Sense VM, the instructions are given. Okay, what we have to do. Most of them are already done. Okay, whenever the lab is setting up, I will show you these instances. Okay, so that's the main thing that you have to do, and there are some files that you have to download when you go with these links. Okay, when you click on these links, you can get all the whatever the required files. Okay, everything is already shared with you, so you can download this file. It's 84.7 MB file, and you have to copy them into your C drive, because I have given a common path, because if you are going to download and extract these files into different places, it will become very difficult to troubleshoot. So what you do is, this is a zip file, that is why you need WinRAR or the normal whatever the WinZip also. Okay, so after you download this file, you can extract into a C drive. Okay, if you extract these files into a different folder, there may be some problems, side effects are there, because because I told you the tool that we are using, Dynagen. So when we are working with Dynagen, there are several paths that we have to set. So if the path are not in the proper place, the Dynagen will not going to work as expected. Okay, so my advice is try to use C drive. Because if you are using another drive, those who are okay with to change the path, if you can have idea, you can change the path and you can still work on. But because there are a lot of people in this session, if you are going to use different partitions, then there may be some different outputs. So troubleshooting will become somewhat difficult for us as well. So that is why my recommendation is you download these files and extract into the C drive. So after you extract this one, you will see these files are there. Okay, then what you have to do is you have to install this Dynagen. You will see this set of file, and you have to install that one. Okay, and you have to install WinPcap as well. So those two exe files you have to install. So these are the only two exe files that you have to install. So after you install these two, the Dynagen, you will see these shortcuts will be there in your desktop. As example, if I show my desktop, okay, you can see all the shortcuts are already created in the desktop. Okay, even though you have 4 shortcuts that coming with this software, you don't want to use all those things. You just need to use this dynamic server shortcut only. Okay, then so that is the main thing that you have to do. Okay, then the other tool that we have to use is VPC simulator. Okay, there's another file, VPC simulator, that is inside the VPC folder, which you can open and see. There are no any installations are there. Directly there is a exe file that you have to run. So you may think that why this VPC? Because when you are creating a network, we need routers, switches, and even PCs. Okay, so with the PCs, with these VMs, we have already got some PCs and servers, but those are server side, but we need some clients as well to check the connectivities. So if you are going to put another VMs to this network, then again, we have a problem with the resources. So we are using a VPC simulator, which is a simple software that you can simulate 9 PCs. 9 PCs means not something like a Windows XP or something, just basic tools are there. Okay, so when you run this VPC simulator, it will create 9 virtual PCs inside your computer. It will not going to take more resources, so that is why we are using that one. Okay, so that is the those are the main concerns that you have to work with. Okay, and because you have to be familiar with this the software, I have put some tutorials for you in the PDF format, and Dynamics tutorial is also there, and VPC simulation PDF also there. Okay, so you can go through them. Now as example, if I show you the Dynamics tutorial, even though it has 49 pages, you don't want to go through everything, but when I do the practical, I will show you how to work with that one. But those who want to check what is this tool and how it works, you can refer this one. Okay, so all the needed informations are here in this tutorial. Okay, that is why I have put that here, so you can get an idea how to create the network. Actually, using this software, we are going to create the network. We are not using any other softwares. Okay, we are not going to use GNS3, we are not going to use Packet Trace or any other graphical software we are not going to use. So this is a totally text-based. That is why sometimes you may get confused. That is why I have already shared this tutorial with you. So if anyone want to get a rough idea, okay, if anyone going to rough idea today before we start this lab setup tomorrow, you can just go through this tutorial and get the kind of idea. And even if you view YouTube, okay, there are a lot of YouTube videos out there about this one, so you can get a kind of you know, introduction about how this software actually works. Okay, so that is about the Dynamics tutorial, and even there is a VPC tutorial as well. Okay, so you can view that one as well. So then you can get idea how this VPCs are working. So that is not a large, or it doesn't contains a lot of pages. It is just only 4 pages are there. Okay, and the whatever the commands that are available in the VPCs and how to use that one, you can easily get idea from this PDF as well. Anyway, we are going to work with these things, so you will be more familiar with these things after we do the practical sessions tomorrow. Okay, so this is the network setup. Okay, so this kind of a network that this is the network setup that we are going to configure. Okay, so all the information that required to configure this network is available on these web pages. Okay, so using the Dynagen, whatever the text-based environment, if I show you an example of a Dynagen file, it's something like this. Okay, you may feel like, okay, this is a text-based, so this is a network actually. So if I show you the network that I have created here as example, so this network, so this is the network setup that I have created here. Okay, to create this kind of a network, you have to code something like this. Okay, so I know a bit confusing how to create a network using this kind of a text-based file. We can do it. Okay, we will do it tomorrow, and we'll see how to get these things done. Okay, so this is a sample. Okay, how to create this kind of a network. If you can see this image, this network setup is done by using this kind of a code. Okay, so these are the virtual PCs, and this is the router. Okay, and this is the switch. Okay, so likewise, I will explain these things step by step tomorrow when we are working with the real lab setup. So before that one, so you have what you have to do is you have to download those softwares, and you have to configure the those softwares and be ready with those things. Okay, and so as I already told you, if I explain what is Dynamics, the same thing, something like DNS3, but it uses the hypervisor or the backend. What you see in the DNS3 is a graphical one, but what is backend is happening is something like that. Okay, using the Dynamics. Okay, so you can view these slides as well in our agenda. If you go, you can see, you can download and go through these things. So that is the introduction to our lab setup actually. So So after you download these things, if you want, you can run and see whether the required softwares are actually working or not. So I will show you if your configurations are correct. If you are already the Dynamics is working, what you have to check is after installing this one, you can just double click and see whether this is loading. Okay, so you can see this is what you see in the front end of the Dynamics. So if you see something like this, if you see something like this in your output, so it means that dynamic service correctly installed in your computer. Okay, and to run the VPC, okay, to run the VPC, what you have to do is you have to go to the VPC folder. Okay, once you download, you will get the VPC folder, and inside the VPC folder, you will see there are two files. Okay, to run the VPC PC simulator, what you have to do is you have to double click on this one, and you will see something like this will appear. Okay, so if you get this window, it means that your VPC simulator is correctly working. Okay, so it has got 9 virtual PCs. Okay, so you can see it has 9 PCs are there. So I will explain how to set IP addresses for this one, but you can see a default there are some IP version 6 IPs are there, and this VPC simulators are using UDP ports. Okay, so they are using UDP ports for the communication. It uses your local computer's UDP port. So you can see the local port is 2000 and the remote port is 3000. Likewise, they are starting from the 2000 and up to 2008 they are using. So internally, a network has been created with these PCs. So we can use IP addresses and we can make it work. We can ping and we can check the connectivity after we correctly install these softwares. Okay, so you will see these two outputs if you have correctly installed Dynamics, and if your VPC simulator is correctly working. Okay, and as example, I will show you a sample network file which I created this one. I will explain how to create this one tomorrow morning session. Okay, because we have to start with the fresh mind tomorrow, because maybe you have already exhausted due to the today workshop. You have learned lot of things and you have go through 2 sessions. So I believe having a fresh start tomorrow morning is the best way to understand this kind of a thing. So even though this I have created in the notepad, when we are saving this file, we have to save this file with the net extension. Now you can see this is the notepad file. I have saved it using the extension is net. So it will save as net file. So if you want to run this network, what you have to do is you have to run the Dynamics first, and whatever the net file you have created, you have to double click on that one. Okay, then it will load the network diagram. Okay, so after loading the diagram, we can see there are 2 routers and 1 switch is running. I know, bit confusing for the first time. I will explain them step by step tomorrow morning. But as a kickstart, I am showing these things. Okay, so if you have correctly installed all the softwares, this is the output you will see. Okay, the network is running now. You can see router 1, router 2, and 1 switch is running, because in this file I am using 2 routers. Okay, I will explain them. One router is 7200 version and other one is 2725 version, and I am using a 1 Ethernet switch. So those things are listed here. Okay, you can see 1 router, router 2, and switch 1. Okay, so if you want to log into the router, okay, what you have to do is you have to have the PuTTY. That is why we need to have the PuTTY installed in your computer. Okay, so what you have to do is, if you want to connect to these devices, all these devices are running on your local PC. Okay, local host. Okay, so all the devices. Okay, so if you want to connect to the router, now there are 2 routers are running here. One router is 7200 router, other one is 2725, 3725. So to connect to this one, what you have to do is you have to type your local host IP, 121.0.0.1. Okay. And here what you have to type is the console port. Here you can see router 1 is using console port 200 and router 2 is using console port 2001. So you have to select here Telnet. Okay, if you are using a previous version of PuTTY, you will see the Telnet option button is here. But if you are using latest one, here you can see you have to select anyway the Telnet you have to use. And here port number, what you have to use is if you are connected to router 1, the port should be 2000. If you are going to connect to the router 2, the port should be 2001. Okay, now as example, if I want to connect to the router 1, which is 7200 router, I have to type here 2000 and here Telnet, and you can open this one and it will connect to the router. Now those who are familiar with Cisco, this is the first message that you will see, because this is a fresh router without any configuration. So normally we use no here. Okay, so you can ignore whatever the errors that are coming. It will go to the user mode. Okay, now you are inside the router. Okay, so normal router commands you can execute here. Show IP interface brief as example. Okay, now you can see the interfaces are there. Okay, you can assign IP address and you can create a network. So something like now those who are worked with Packet Tracer or GNS3, the final output is this. Okay, so in a GNS3 you are using a graphical router and you will right click and go to the console. But here the path is different, but the final output is the same. The only thing is we are creating the network without graphical interface. We are using a text-based technology or a tool to create the network. That is the only difference. So actually this is the back end of the GNS3. Okay, the previous version of before GNS3 becomes the graphical, this is how they have worked with GNS3. Okay, so if I want to connect to the, let's say, router 2, so you have to get the PuTTY again. Okay, I will create 2 sessions because I need to show you in 2 different. Again 127.0.0.1. Okay, the console port here, it is using 2001. So 2001, and you have to select Telnet here. Okay, and open. Okay, then again you can say no, and you can wait. It will load it will go to the user mode. Okay, so the main advantages is not like GNS3. This is using very limited resources. Okay, so that is the main concern that we had, because without using a lot of resources, we need to configure this one in one computer. That is why we are using this tool. Okay, even though sometimes a bit confusing, after you become familiar with this tool, it is very easy to work with this one, because it uses limited resources in your computer. It very fast and you can work with that one. So now this router is a different one. Okay, show IP interface brief. Okay, so it has different configuration. Even you can check show version. Okay, so it is C325 router, and this one show version. Okay, this is 7200 router. Okay, so this is how the lab setup is going to work. Okay, I know this is some I explained this in somewhat fast because of the half an hour that we have got. But if you have any problems, we will go through this one again tomorrow. And you can ask any question if you have any confusing areas. You can refer us and get our feedback. Okay, but you have to remember that now due to the workload or due to the services in your computer, maybe some issues can happen, because sometimes I have experienced sometimes this dynamic server may not open. Sometimes if you are working, after several times, if you double click on that one, or if you force that software, maybe it will not going to work as intended. So sometimes you have to restart the computer and you have to get back to the console. So that kind of things can happen. So you have to bear with those kind of things. But normally, if your computer is a performing one, if you don't have any viruses inside your computer, so normally the software will run without any issue. If you come up with an issue, you can talk to us. Okay, so most probably after restarting, most of the issues are resolved. Okay, but I don't believe that everyone has to do again and again it. Okay, so that is a kind of an overview of what we are going to do tomorrow onwards. Okay, so go to our website and download the required softwares. You always better to use the latest softwares, latest VirtualBox and everything that you are using. So that's all I have to tell you in this session, because almost it's now 4 p.m. Any questions from your side that you need to clarify?
Excuse me.
Yeah.
Is there any compatibility issues with Windows 11?
Actually, we have tested this one with Windows 8 and Windows 10 only. I don't think that there may be a lot of issues, because still it is a Windows. Okay. The only thing is now, best thing is now you can download this, the third one, the lab mirror. You download those files and extract and see this if this dynamic server is working. Most of the time it's okay. Okay, so you just install this Dynamap server and double click on that one, see whether it is loaded without any issue. If it's loading, most probably Windows 11 also okay, because actually this software is built on I think 1998 to 1994. So they actually somewhat older software, because before the GNSC, this old invented by those people. So it's working. So since then it's working with because they are not recommending to run in Windows 10 even, but it's working in the Windows 10, because I think Windows doesn't have that much of issues with the whatever software that they are running. So I hope there may be no issues with the Windows 11 as well. So you install Dynamics and double click on this one, and if it is loaded like this, most probably you are okay.
I got it. Thanks.
Okay,
Thank you.
Okay. Any other questions? Any other issues? Anyone? Okay then, so it's almost 4 p.m. I'm going to wind up the session for today. Hope everyone will join tomorrow at 9:30. And meanwhile, please download all the softwares and be ready with the VirtualBox and all the other softwares. So if you're having any problems of installing those softwares, you can contact us tomorrow morning. So then I'm going to wind up the session for today then.
Geetika, I think we can announce that. So if they got a problem the night, so even they can talk over the phone to you. I mean,
yeah.
Okay.
Useful
For them, because if they can get these works done, so that's going to be very easy for them to do the rest of the work tomorrow. So if you got any problems during the work tonight, so just make a call to
you can call me on
Geetika contact number can be found on the LAN website. So go to the LAN contacts at the end of the page, at the end of the contact page, there's a link called staff. At that page, you can find the Geetika contact number.
So you can contact on that one if you have any problems. So okay then. So any special notice that you have to give?
Not from my side. So that's the end of the day. So wish you a good day. We shall meet tomorrow morning at 9:30.
Okay. Thank you, sir. So thank you all of you. We'll continue from tomorrow onwards. Thank you for joining.